Hello everyone, welcome to today's class. So we are going to start with the first chapter, that is sets. Okay, so let's see what is a set. So let's begin. So set is a well-defined collection of object. See, collection can be of anything, okay, but well-defined, what is the meaning of then well-defined? If I have to simplify it, well-defined means it should not matter whether I am defining the collection or you are defining the collection. Means opinion should not matter. Okay. So collection of things, collection is basically objects that are being collected in any way. But well-defined means that the perspective of that should not matter by opinion. Let's understand with the help of an example. It will be much more clarified then. Okay. So the question is, which of the following are sets, and we have to justify. Justify means we have to define, justify whether it is well defined or not. If it's well defined, then yes, it is a set. Otherwise, no. So see, the collection of all months of the year beginning with letter J. Now, we all know January, June, July, like this. We can define it. Now, it doesn't matter if I am answering this, I am defining this collection, or you are defining this collection. It won't make a difference. That means it is well defined. And if it is well defined, it is a set. Okay. So all you have to think is whether the opinion matters or not. The collection of 10 most talented writers. Again, see, most talented, it depends, it varies from the opinion of the person. I may think that Munshi Premchand should be in like this top 10, and somebody else might think somebody else should be there. So most talented, this is pretty much ambiguous. It's not well defined. Here opinion will matter. Top 10 list of mine and top 10 list of yours will be different. So it's not well defined, hence not a set. Okay. A team of 11 best cricket batsmen of the world. Again, best. Now best is relative. I may think Virat, Sachin, somebody else may or may not. So again, opinion matters. So not a set. The collection of all boys in your class. So suppose there is a class and all the boys are there. It won't matter if I am doing the collection of all the boys or somebody else is saying who are the boys in the class. Because the class is fixed, so the boys in that will also be fixed. So the collection of the boys is clearly well defined. Opinion will not matter because all the boys that are present in that particular class will be same. So opinion does not matter, hence it is well defined, hence it's a set. Collection of all numbers, natural numbers less than 100. Again, think of the numbers that are less than 100. You'll start from 1, 2, 3, 4 and go up to 99. So if I am giving the answer for this collection or you are giving the answer for this collection, it's same, 1 to 99. So opinion does not matter. If opinion does not matter, it's well defined, hence a set. Collection of novels written by writer Munshi Premchand. So in his particular lifetime, he may have written a lot of novels. So collection of all that is fixed. If I say best novels, then it's ambiguous because best is relative. It depends from person to person. So opinion will matter. If the question becomes collection of best novels, then opinion matter. If the question is saying only like collection of novels, so that is fixed. The number of books that the person has written is fixed. So opinion does not matter. Hence it's well defined. Hence it's a set. Collection of even number. So if I am writing even numbers or you are writing even numbers, it will be same. All even numbers. He is saying all even numbers. So all even numbers. So 2, 4, 6, 8, and then go on. So you will also like answer like this. Okay. So again, set. Okay. So I hope you understand what is the meaning of well defined. So in order to check well defined, you check this, that opinion should not matter. Okay. I hope now you can understand what is a set and what's not a set. Okay. Now there are certain notations that we'll be dealing with a lot in other chapters also. So those notations should be clear. Set of all natural numbers will be represented by capital N. That's fixed. Okay. Set of all integers, positive as well as negative numbers, it will be represented by Z. Then set of all rational numbers. Rational numbers are in the form of P by Q. They will be represented by Q. That's fixed. Okay. All the real numbers, they will be represented by R. Okay. Then suppose I have to set say the only positive integers. I'm talking about integers, but only positive integers. So positive integer will be represented by Z plus. So if I have to specify positive, I'll just apply a plus sign in front of it. It is set of positive integers. Q plus set of positive rational number. R plus set of real positive numbers or positive real numbers. Okay. So these alphabets you should know, that Z means integers, Q means rational number, R means real numbers, okay, N means natural number. All right. Then one particular symbol that we have to deal, it's called belongs to. Now what is the meaning of it? Okay. So first of all, I'll tell you how a set is being represented. So usually you'll write the elements present in. So right now say A is a set and it is being represented in curly brackets. Each number that is written is called element. Okay. They are all elements, so there are 6 elements present inside it. All right. And this belongs to means we have to check whether a particular number is present in that particular set or not. This belongs to deals with that. So if I say A belongs to capital A, what is the meaning of it? That element A is present in set A. Okay. Small a is the element. This symbol reads like belongs to. Capital A is the set A. Okay. So we have to check, we have to insert the appropriate symbol. So it is saying 5, we have to put the symbol. This is belongs to. This one, a slash is there, that means does not belongs to. So all we have to do is check whether the number that is given is present in the given set or not. 5 is present here, so that means it belongs to A set. 8 is not present, so it does not belongs to. Okay, like this. 0 again is not present in this. Only 1 to 6 number are there, so it again does not belongs to. 4 is present, so belongs to. 2 is also present, belongs to. Okay. And 10 is not present in this set, so again it does not belongs to. Okay. So if some element is present inside the set, we'll say belongs to, otherwise it does not belongs to. Okay, whatever element is present inside it. Okay, now I'm saying this is a set. Right now I have not discussed a representation of set, but you get some idea that how a set is usually represented. Curly brackets, and inside we'll write elements. Elements are the collection, whatever collection or whatever condition is being followed. Okay. So let's start with the representation of set now. Okay. Representation of set. Basically there are 2 categories. Okay. one is roster form, one is set builder form. First I'll talk about roster form. Roster form is the simplest one of all. The rule to write any set in roster form is all elements are written which satisfy the condition. And more importantly, they are written in curly brackets. So always whenever we write set, we always write in curly brackets. Okay, and each element they will be separated by commas. Okay, there's one more rule that you should know. This is the first one. Second one, more important one. Each element is written only once. I'll explain this with the help of an example. But right now in roster form, each element is written only once. We cannot write same element twice or 3 times. Okay. Let's see with the help of example how this thing is working. So we have to write the following sets in roster form. So here's defining. I'll explain what are the symbols, what is the notation being followed. So he's saying, first of all, a curly bracket x. So x is basically the element in the set. Okay, so we have to look for the values of x first of all. So it is defining which variable's value or condition we have to look for. We are looking for x. Now this double dot means such that. So x is such that x is an integer. Okay, double dot means he's now telling us about the condition such that x is an integer. Okay, fine. And it is now we have to read like this. First of all, read the half part of it. It is x is greater than equal to -3 and it is less than 7. So we have to think of the numbers which are greater than or equal to -3 but less than 7. So what are those numbers? So I'll write set A is first of all curly brackets, then I write the numbers starting from -3 itself because equal to is present. If equal to is not present, then I'll move to the larger number, that's -2. Then separated by comma, -2, -1, 0, 1, 2, 3, 4, 5, 6 only, and curly bracket close. Okay, so less than 7, greater than equal to -3, all the elements are being written. These are called elements. Okay, the numbers which are satisfying the condition. So now we know how to read the condition. Let's do a few more examples that will help you to clarify. B set x, so we have to look for x such that x is a natural number less than 6. So think of all the natural numbers that are less than 6. Everyone knows natural numbers start from 1, 2, 3, 4, 5, but we don't have to write 6 because it's saying less than 6. 6 is not less than 6. So we will AND it. Okay. Next, C is saying x is such that x is a 2-digit number such that sum of its digit is 8. So we have to write all the numbers, 2-digit numbers, natural numbers, whose sum of digits is 8. So I'll say let's start with simple 2-digit numbers. So I have to write 17, then 26, then 35, 44, then 53, then again reverse of this 62, then 71 and 80 also. I'm not taking 08 because 08 will not be considered as a 2-digit number. Okay, so sometimes usually this is the number that is missed. Most of the students think about these numbers only. First 80 is also a number, 2-digit number whose sum of digits is 8, but 08 will not be included. Okay, So 17, 26, 35, 44, 53, 62, 71, 80, and that's it. All the numbers that is satisfying the condition in curly bracket separated by commas. Not last, D. X is such that X is a prime number which is divisor of 60. So I have to think of prime numbers which are divisor of 60, means which divides 60. So prime number starts from 2. So 2 of course can divide 60. 3 can also divide. 4 is not a prime number. I have to think only prime numbers. So 5, yes, 5 divides. 7 does not. And then after 7, 11 again does not. What else? I think pretty much we are done. After that, no other prime number will be dividing 60. Divisors can be many more, but only these are the prime numbers. Basically, you do the prime factorization, you will get the factors of 2, 3 and 5 only. So these are only the numbers that satisfy the condition. Prime numbers and divisor of 60. So 2, 3, 5. Now, the simple one. Set of all letters of the word trigonometry. So for this I have to write the letters. I have to write all the letters. So T is there, I will write T. Okay, I'll cancel one alphabet at a time. So T is there, so I'm cancelling T. Then R is there, so I have to cancel R. Then I is there, I'll cancel I. Then G is there, cancel it. O is there, so O. N. Now again O comes. So I told you that each element is written only once. Since we have already written O, it does not matter. So it doesn't matter O is coming many times. Since we have already written O, I'll not write O again. So it's already included. M we have not written, so M. E we have not written, so E. T we have already written again. See, T we have already written, so I'm not write T again. R I've already written, so I'll not write again. And Y is not written. So this is the meaning of the second condition that I've told you, that each element is written only once. No matter how many times it is being repeated, we'll write only once in this. Same thing in F also. Set of all letters in the word better. So all the alphabets or all the letters starting with B, E. Now T is being repeated, so I'll write T only one time. E is already covered, so will not write again. And then R. That's it. That's your roster form. So now you know that element can be written only once inside a roster form. Okay. I hope that clarifies roster form. It's one of the simplest one. All you have to do is understand how you read this. It's read like this: X double dot means such that, and then you read the condition, and the values of X which satisfy the condition will be your elements of the sets. All right, we're done with this. One more thing. I'll insert some space. One more point was that order of element does not matter. In set means, suppose I say A set is, I can write 1, 2, 3 in the increasing order, or I can write 1, 3, 2. Does not matter. Both are equivalent. Both are same. So both are correct. So it doesn't matter. Since although I have written in increasing order, but it's not the condition. You have to understand that both mean same thing. So first, order also does not matter, and element is written only once, not being repeated anyway. Okay. All right. So that covers your roster form. Now comes set builder form. I didn't explain set builder form before this. Let's erase this. The reason is that these questions that we were doing, these are actually written in set builder form. Okay, means somehow elements will be given to us. We have to find a unique relation that is in those elements, and based on that we have to write the condition like this. Okay, so basically in set builder form what we have to do, write a unique condition which satisfy all elements. Okay, all right, let's see. First part, it's saying the numbers are 3, 6, 9, 12. So 3, 6, 9, 12. Okay, first of all you can see that these numbers, they are all multiple of 3. 3 into 1, 3 into 2, 3 into 3, 3 into 4. So I can say the numbers are multiple of 3. So in roster form there is again a way to write it. Let's call this as set A. We can name the set. If it's not given, we can name it anything. Let's call this a set A. Then curly bracket start. We'll verify for every element we'll define a variable, usually x. Okay, x. Then double dot, and now we start writing the condition. What is the condition? That x is a multiple of 3. Okay, this is one way. But see, multiple of 3 are 15, 18 also. So somehow we have to restrict also. Okay, so slightly better way to write multiple of something is by writing this condition, x is equal to 3 into n. Okay, now we think n can be 1, 2, 3, 4, something like that. Now we'll apply the condition on n. If it is 3 multiple of 3, we'll write 3n. If it is multiple of 4, we'll write 4n. If it is multiple of 5, 5n. Now let's apply the condition, but again we have to specify what is n. N, first of all, I'll say n is belonging to natural number. So that automatically means I have to consider the value of n as 1, 2, 3, 4, 5, 6, 7, 8 and so on. But since the values are only till 12, that means n should be less than or equal to 4. N cannot be more than 4, because if n is 5, if I put n here 5, 5 into 3 is 15. 15 is not the element, so I'm restricted till 12. In the table of 3, 12 comes at 4th position, 3 into 4. So n should be max to max 4. Okay, I know it's a lot to take in, but try to understand how I'm devising the condition, because all the rest of the questions will be based on these ideas. First of all, a variable such that, then multiple of 3, instead of writing in language multiple of 3, I'm writing x is equal to 3n. Then I'm telling n is natural number, and n, since natural numbers are infinite, so I have to restrict n to such that it gives us the maximum value, that is 12. So for that n has to be 4. 4 into 3, 12. And now I close the condition. Sorry, close that. So I hope this is pretty much clear here. Okay. Second, 2, 4, 8, 16, 32. There's a pattern that is followed. Again, you can pretty much easily identify that every time the number is being multiplied by 2, so the powers or 2 basically is being raised. Okay, so let's call this as set B, again the dummy variable x, such that x is equal to, now what we have to write, I cannot write 2n because this is not a table of 2. Instead 2 is being multiplied every time. If you look at very carefully, you will find another way. First of all, this is nothing but 2 raised to power 1. If you look at this carefully, this is 2 raised to power 2, this is 2 raised to power 3, 2 raised to power 4, 2 raised to power 5. So power is being raised every time. So I can say this is 2 raised to power n. And now I apply the condition based on these, okay, based on these powers. I will apply the condition on the power n. So what is the value of n? First of all, let's define that n is first of all natural number. We cannot take 1.2, 1.3. Then I have to restrict n to the maximum value of 5. So I'll say n is less than equal to 5, and that's it. Okay. I hope this is clear. Fine. Next example. You can try this. This has same idea as second question, so I'm not discussing. Take it as homework to attempt. Okay. I'm discussing the fourth one. Fourth one is 2, 4, 6, 8. Not 8 is not there, but there is dot dot dot. First of all, what is this dot dot dot? Means this series will continue till infinity. So first of all, these numbers are what? Even numbers. So it can be written like this, that C is such that x and x is an even number. We can write in language also. Okay. Or we can write x is multiple of 2, means 2n, and what is n? N belongs to only natural number. We can write directly that x is an even number, or x is 2n and n belongs to natural number. We are not restricting n to any value, because don't think that 6 is the last value. These dot dot dot, it means this series will continue, and till where? Till infinity. So I am not restricting my small n also. Okay. Fine. Last one. 1, 4, 9 dot dot dot. Again, dot dot means you have to identify the pattern till 100. Now this time it is restricting. It is not listing all the values, but it is restricting till 100. So let's call this as set t. So first of all, if you look at the number, you will see that the numbers that are given, they are perfect square. 1 square, 2 square, 3 square. Then lastly it is 10 square. So that means x is such that x is equal to, I'll say, n square. Now n is clearly this. One, 2, 3 up to 10. Okay. So that means n is belonging to, first of all, natural number, but I have to restrict n to max of 10. So n is less than equal to 10 also. We cannot go beyond 10. If n is 11, 11 square will be 121. That is not present in this set. So I have to restrict n here. Okay. Yeah, thanks. So those pattern will help you to identify that whether you should put restriction on n or not, and till which point. Okay. I hope this pretty much clarifies how we have to deal with set builder form. Okay. And if you want to practice more, what you do is just look at these numbers and try to write the set builder form in this. So you already have the answers. All you have to do is try to write down the condition for these solutions, that this is trigonometry. So clearly these are alphabets of the word trigonometry. So you write down such that x is all the elements of the, sorry, it is a set of all the letters of the word trigonometry. It is all the set of all the letters of the word better. Okay. For numbers, we'll have to think what is the condition. Okay. 2, 3, 5, there are multiple ways. Okay. Suppose you are doing this as a attempt at home. You're writing a condition on 2, 3, 5. See, your relation can be in any way. Sometimes the numbers can have multiple relations, like 2, 3, 5. If I look at these, I'll say these are the prime number less than equal to 5. Okay, all the prime number less than equal to 5. I can define it like this also. It's not necessarily that you have to always arrive at the same set builder form. Okay. So as long as the relation is correct, all of them is correct. And more importantly, if you are doing the exam, you will have MCQs. So all you have to do is check. Check from the option. Whichever option satisfies, that will be correct. Okay. Fine. So that covers your representation of set. Let's move to the next topic. Types of set. Okay. So there are different types of sets. Now again, this is slightly theoretical in nature. You try to quickly understand by the name itself. Okay. The name itself give it away. You don't have to learn anything. So I've given you the definition. They will not directly ask you for the definition. You have to understand it. One second. Okay. Empty set. Clearly the word empty is there. That means it should not have any element. That's it. Any set which does not contain any element, it's called empty set. Now there are multiple names for it. It's called empty set. It's called null set. It's also called void set. So the name should be familiarized. Okay. Suppose in the option they don't give you empty set, they may have given you the null set or void set. Okay. Now the symbol of this, first of all, empty set, it is being represented by symbol. Okay. So how it is represented? It is represented by phi or curly bracket. Curly bracket means set, and you don't write anything inside it. So it's empty set. But usually we prefer this notation phi. Okay. All right. Let's look at some examples and we have to see whether they are empty set or not. So let's read down the condition. X double dot means such that x should be greater than 1 and less than 2, and x is a natural number. Now think between 1 to 2 on the number line, 1 and 2. There are no natural numbers in between them. There are fractions or decimal between them, but there is no natural number present. So I cannot write anything inside A. So that means it is nothing but a empty set or null set. Okay. Similarly like this, x square minus 2. So let's read out from the start. X is such that x square minus 2 equal to 0. So we have to see whether this condition is satisfied or not. So if we solve x square minus 2 equal to 0, so we get x square equal to 2, x is equal to x is equal to root 2. Wrong. Plus minus root 2. Two solutions. You should know this. Very common mistake that whenever square is there, it will generate two roots, positive as well as negative. If you know this, good. If you don't, keep this in mind. It will help you in the later stage. So yeah, so root 2. So root 2 is not a rational number. This is clearly irrational. If it's an irrational number, how can x be rational then? No, not possible. We are getting the value of x, but it is not rational. So again, your set B is again also no x value of x is satisfying both the condition, and is there. No? That means we have to satisfy both the condition. We are getting x is plus minus root 2, but it's not rational. So no element is satisfying this. So empty set or phi. Next definition called singleton set. Now the singleton means the word single is there. This gives it away. Singleton means it should contain only one element. This set B, x square minus 2 equal to 0. We got two values. It's not a singleton set. It's not a singleton set. There is no name for two elements. For single element there is name, or one element there is a name, singleton. Suppose I give you a set example. Let's say this is a set C. C curly bracket, x is such that 2x plus 3 equals to 0 and x belongs to real number. Okay. So if we solve this, how many values of x we are going to get? Only one. If we just try to write down in the roster form. So if I try to write down in the roster form, the value will become, if we solve this, you will get 2x plus 3 equals to 0. So x is equal to minus 3 by 2. So minus 3 by 2. and that belongs to real number. So one value is there. So I can say C set is a singleton set. It's as simple as that. If there is only one element present inside a set, it's called singleton set. In order to judge any kind of or type of set, you write them in the roster form and then judge what kind of set it is. Okay. Next, finite and infinite set. Again, the words, they give it away. Finite set means it will have definite or finite number of elements. Otherwise, it will be called infinite set. Okay. Let's look at this. One example. State which of the following sets are finite or infinite. So all we have to do is judge. If we write down this set in the roster form, what do we write? X belongs to natural number and x minus 1, x minus 2 equal to 0. So if we solve this, we'll get two values, 1 and 2. I hope everyone knows how to solve this factorized form. If you are doing 11th, 12th maths, I am expecting that this one you should know. Basically, you solve separately for x minus 1 equal to 0, you solve x minus 2 equal to 0. You solve them separately, you will get x equal to 1 and x equal to 2. You solve them separately. So 1 and 2. So two values. So this is finite. There are finite number of elements, na? Definite number of elements. Two elements are there. Now, x again belongs to natural number and x square is 4. So if x square, okay, I'll erase this. Erase this also. Let's focus on only finite set. So x square equal to 4. So that means x is equal to plus minus square root of 4, that is plus minus 2. So two values. But no, we have to satisfy this condition as well. X belongs to natural number. So minus 2 is not a natural number. That means in the roster form, we'll write only this. Since it contains one element, so again finite set. And as well as a singleton set. This is a very smart way to judge this. Like quadratic equation, everyone may think that quadratic has two roots, so two roots means two values, so must not be a singleton set, but we have to satisfy both the conditions simultaneously. We are getting two values, but why I am writing only 2? Because x should belong to natural number also. Minus 2 is not a natural number. Third one, write down in the this. X is a natural number and 2x minus 1 equal to 0. 2x minus 1 equals to 0. So x is 1 by 2. But it should be a natural number. Can we write a natural number in it? No. So no element is present. So 0 element is there, still finite. Okay. Even if you have 0 elements, still finite. Okay. Then x belongs to natural number and x is a prime number. Start writing the prime numbers. So you'll start from 2, 3, 5, then 7, then 11, and so on. And you keep writing it because there is no restriction present. So we have to keep writing this. So that means dot 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 we have to write like this. We have to go for the long series here. So and it will never end. So now how many elements are there if I ask you? So there are infinite elements now. So it's an infinite set. Lastly, x belongs to natural number and x is odd. Again, if I talk about odd number starts from 1, 3, 5, 7, and we have to keep going on because the question itself does not restrict x belongs to natural number. So again, we have to go till infinity. So how many elements are there inside it? Infinite. So infinite set. Okay. It's as simple as that. So basically, if you are comfortable writing the roster form of any set, you should be able to identify whether it is a equal set or finite set. Sorry, equal we have not discussed. Whether it's an empty set or singleton set, finite set, infinite set. Okay. Next comes a cardinal number. Now, if you don't know the word, it might confuse you, but it's a very simple meaning here. Cardinal number means number of elements that is present in any set. So I'll give you one example for this. Let me create some space first. Okay. Suppose you have a set A that is A, B, C, D, okay, and ask you that what's the cardinal number, means what is n of A. So how many elements? All you have to do is do the counting. How many elements are there? 1, 2, 3, 4. So 4 elements are there. Okay, fine. I'll give you one tricky example also. This will come in one of the upcoming question it is there, but still let's introduce it before. Okay. Now try to answer it. Okay. How many elements are there in set B? Okay. If you look at very carefully, the very obvious answer is 5. Okay, 1, 2, 3, 4, 5. So 5, but it's wrong. The reason yet, if you look at very carefully, I have placed a curly bracket between 3 and I have placed 3 and 4 inside a curly bracket. Basically, what does that imply? That inside the set B, another set is there. Now, it might slightly confuse you, that set inside a set, but yes, it can be done. We'll discuss this in power of set. But right now, if something is present, if this curly bracket is present, so this is effectively a set. If it is a set, treat it as a single element. That's the key aspect. Treat it as single element. And now count it. Okay, let's count it. 1, 2, this effectively 3 and 4. So what is the correct answer for this? 4 is the correct. 5 is wrong. Okay. So if a set is present inside a set, that particular set will be treated as a single element, not as 2 different elements. Okay. All right. Fine. Then comes equivalence set. What is the meaning of equivalence? If 2 sets are there, A and B, and number of elements of set A is equal to number of elements of set B, it's called equivalence set. Means does not matter what element is, it's just that their cardinal number should be same. If set A has 4 elements, set B should also have 4 elements. These two, the examples somehow that I've created, they are perfect example that they are equivalence set. The elements are different, but number of elements are same. So we are concerned with number of elements, not the elements itself. However, if the elements itself are same, exactly the same, if 2 sets have exactly same elements, we call them as equal sets. Okay. If both of them should be having same elements. Let's see. Let's start with this example. A, B. A has 2, 3 and B is written in roster form x such that x is a solution of this equation. So let's solve this. X square plus 5x plus 6 equals to 0. So x square, middle term spreading, x plus 2, x plus 3 equals to 0. X is equal to minus 2 and minus 3. So basically if I write down B set in roster form, that's minus 2 and minus 3. Can I say A and B are equal now? Try to think. Are they equal? So for the first part, A is 2, 3 whereas B is minus 2, minus 3. So they are not equal. A set is not equal to B set. For the second part, let's write down in the roster form. A set. Letter of the word follow. So let's write down F is there, O is there, L is there, written twice, but we'll write only once. O is already written, so we'll not write again, and W. Similarly, B, B is the letter of word wolf, so W, O, L and F. Now order is different, but if we look at very carefully, F is there, F is there, O is there, O is there, L is there, L is there, W is there, W is here. I told you that order does not matter in a set, so they have exactly same elements. So yes, for the second case, A is equal to B. Set A and set B, they are equal. Okay. I hope whatever I have explained till this point is clear. Okay. Fine. Now let's move to the next subtopic, that is subset. Okay. Now subset, it's easy as well as sometimes it's very tricky also. Okay, try to understand it. Okay, all right. I'll rewrite this example. So you have a, first of all, definition. Let's see the definition. So he's saying that a set A is said to be a subset of B. Okay, first of all, symbol of subset is like this. A is subset of B, na? So subset symbol is this. Okay, it's called, now A is subset of B if every element of A, means all the elements that are present in A, is also element of B. Okay, let's understand with the help of an example. A set is 1, 2, 3. B set is 1, 2, 3, 4, and C set is 1, 2, not 1, 2, 3, 3, 2, 1, 3, 2, 1. Okay. Now if I ask you that A is a subset of B, is it correct or not? So again, just follow the definition. All the elements or every element of set A, 1, 2 and 3 must be present in set B. It is there. So yes, it's correct. Okay. If I talk about C, C is a subset of B. Again, for that, all the elements of set C, that is 3, 2 and 1 must be present in set B. So yes, that is correct. Okay. If I reverse it, let's say I say B is a subset of A. Okay, it's a U. Okay, in this direction. Now all the elements of set B, 1, 2, 3, 4 should be present in set A. 1, 2, 3 is present, but 4 is not present in set A. So B cannot be a subset of A. Wrong. Absolutely wrong. B is not a subset of A. Okay, so if A is subset of B, all elements of A should be present in B. Basically, it is a slight portion of the whole set B. Means you take out some piece of set B and put it in a set A. That's the idea. How big of that piece is depends on you. Okay. Now, I want to define one condition. Sometimes it is usually directly asked that A is subset of C. Is it correct or not? All the elements of A are present in C. Yes. And C is also subset of A. All the elements of C are present in A. If both of them are correct, what is the final conclusion we can draw? If A is subset of C and C is also a subset of A, the conclusion that you can draw that A and C set are equal, which you can clearly see. Of course, you might think what's the point of saying that, like we can directly say C set A and set C, they are equal. But point is, usually when they want to ask you this, when they want you to answer this, they will not give you set A and set C. They will give you this condition only, that if A is a subset of C and C is also a subset of A, that is, what is the conclusion that you can draw? The conclusion is that set A and set C are equal, and this is justified based on the example. Okay. Now let's leave this topic for the time being, and let's understand a little more about subsets. Let's see how we can generate subsets. One more example. Write all subsets of 1, 2. A set is there. Okay, you have to write all the possible subset. Okay. Now let's take one example that will complete it. 1, 2 and 3. Okay. Now how do we write subset? Okay. In order to write subset, the idea was to take a piece of set A. Okay, so if I have to take piece of it, I'll take one piece at a time. So let's start. If I take only one element, only one element is taken. So what kind of sets can be created? You can think like, suppose we take only one, this is a subset of A. If I take only 2, it is also a subset of A. If I take only one element, that is 3, it's also a subset of A. So I've taken only one element and I've created subset. Okay. Now take 2 elements. So now I have to take 1 and 2 and create a set. Creating set means put in a curly bracket. Then I can take 2 and 3 also, put in a curly bracket. I can take 1 and 3 also. And don't think that 3 and 1 also should be there. I told you that order does not matter in a set. What if we take all the elements? That can also be way. So 1, 2 and 3. But something is missing. What if we take 0 elements? If nothing is taken, that means we don't write anything inside the set. Means that is phi. Now these are all the subsets which are of the set A. Now let's count it. How many are there? 3, 3, 1, 1. So total 8 subsets. Okay. 8 subsets are there for set A. Okay. Now let's understand few key points. From this. First of all, phi is subset of every set. This phi would have come even if there were 2 elements, 1 element or 0 element or 10 elements. This phi would have already come. So that means phi is subset of every set. Second, every set is a subset of itself. See, 1, 2, 3. This 1, 2, 3 is a subset of set A. 1, 2, 3 means every set is a subset of itself. A is a subset of A. Okay. And third, number of possible subsets is equal to 2 raised to power n, where n is number of elements. Look at this. How many elements are there? 3 elements. So what is 2 raised to power 3? 8. So without actually writing all the subsets, we can tell how many subsets are already possible. That is 2 raised to power 3. Okay. So if there were 4 elements, 2 raised to power 4 possible subsets. So 16. It will take a lot of time to write down 16 subsets, but yes, we can. All right. Fine. I hope this is clear till this point. Key points, remember, they can be directly asked in your MCQs. Phi is a subset of every set. Every set is a subset of itself, and number of possible set is 2 raised to power n. You can consider this as a formula itself. Okay. They may ask you directly. 2 raised to power n. All right, that pretty much covers some idea about subset, how we can generate subsets. Now let's start with this. Power of a set. Okay. Now, power of set, let's look at the definition. The definition says it is a collection of all subsets of set A. That means collection. First of all, he is saying collection. So let's highlight that word. Collection. Collection means it's power of power set itself is a set. Okay. So it is usually represented by P of A. If you're talking about set A, if you're talking about set B, then P of B. Okay. So it is collection. So it is also a set. So we have to place curly brackets, and what we have to write inside it, all the possible subsets, means these possible subsets. Okay. I have to place this inside here. Okay. If I write all the possible subsets separated by comma inside a set itself, this thing is called power of set. Okay. Fine. All 8 subsets are written inside a set called power set of A. Okay. All right. So collection of subset is called power set. Simple enough. How many elements are there again? You can tell by number of possible subsets, 2 raised to power n. Okay. Now comes the next topic. Intervals as a subset of R. Now I'll explain this very quickly. It's very simple. First of all, it's called open interval. It's called closed interval. I'll tell you why closed, and these are closed, open, open, closed. What is the meaning of it? We'll talk about that. Okay. So for this, what is the meaning of this? Clearly, suppose this is a number line, and I am highlighting this part, na? A to B. But if you look at this, there is a hollow circle present on A and B. That means those particular values are not included. Okay. Those values are not included. Now this is represented by open bracket AB. Open bracket AB means from A to B, and A and B both are not included. So basically, if this is a number line, so I will say that it is representing interval. Which interval? X is greater than A but less than B. So between A and B, but both of them are not included. Remember that if bracket is curve, that means open interval, means that value will not be included, means A will not be included, B will also not be included. If I talk about closed bracket, now on the number line we'll represent this by solid dots. So solid dot means these values are being included, and in interval form we'll write this as closed bracket A and B. Now closed bracket means that again the numbers are between A and B, but both of them are being included. That means equality is there, means X is equal to A and X is equal to B is also possible, means these end values are included in it. Okay. Then this is now pretty obvious. If it is square bracket means closed interval, means A will be included. So you can see a solid dot on A. That means this value will be included, whereas curve bracket, that means open interval. So at B, a hollow dot is there. Okay. So that is X should be greater than equal to A but less than B. Lastly, again reverse of it. So this time open interval, this curve bracket, that means open interval, that means A is not included, whereas square bracket, that means closed interval on B, so B is included. Okay. If you're still unable to understand, you can pretty much easily understand this with the help of this example. I think numbers usually makes more sense than variables. So x is such that x belongs to R, and this is the interval that is given to you. You have to write this as interval. That means you have to write this curve in the form of brackets. Okay. So close bracket or open bracket. Okay. So first of all, there is no equality present on this 4. No equality, that means open bracket, means curve bracket. So I'll say x belongs to, let's put it like this, belongs to -4 open bracket, and equality is present here on 6. So 6 but square bracket. So first, what is it representing? It is representing all the numbers that is present between 4 and 6, but 6 is included, -4 and -6, but 6 is included, -4 is not included in x. Means I can assume x is equal to 6, but I cannot assume x equal to -4. Same here. No equality present, that means x belongs to bracket -12, say -12 to 10. Okay, sorry, -10, -12 to -10. And since no equality, so open interval is represented by curve bracket, not square bracket. Okay, first part, second part. This is not too much directly related with sets as such, I'll say, but this will help you when we'll talk about domain and range. In that particular thing, we'll talk about the values of x, what are the possible values of x, and there we'll write the answer in form of this, that x belongs to these numbers, all the numbers that are present between -12 to -10, but whether -12 and -10 are included or not, that depends on this bracket itself. Next one, if you look at equality present on 0, no equality present on 7. So I'll write x belongs to 0 to 7, and equality present, so square bracket, no equality present, so open bracket or curve bracket. Third part. Fourth one, try to judge it yourself. Equality, so x belongs to 3 to 4, all the numbers that are present between 3 and 4, but equality is there, so square bracket, square bracket. It's as simple as that. So basically you have to follow the notation. This means included, this means not included. In this you will have equals to present, in this you will have no equal to present, equal to not present. Okay, equality is there, equality is not there. Let's erase this, otherwise it might confuse you. Include and not does not include. Okay. Okay. Fine. So interval is clear. Let's do a few questions based on subsets to have slightly better understanding. Let's do one example first. It's saying examine whether the statements are true or false. Okay, so we have to read as the following. First one, a comma b, this is a set, is not a subset. If slash is there, that means not a subset of BCA. Clearly a and b are present in here, so it is a subset, so this is false. AE is a subset of this. Now we have to convert this in roster form first of all. X is such that X is vowel of English alphabet. Vowels are A, E, I, O, U. Curly bracket close. Again, A and E are present here, so it is a subset. That means this is true. 1, 2, 3 is a subset of 1, 3, 5. 1, 2, 3, all elements should be present here. 1 is present, 3 is present, 2 is not present, so false. A is subset of, this set is a subset of ABC, so A must be present in ABC, So it is present, so true. Now this is interesting. I'll explain this, why this is wrong and how we can actually correct this. Now if you look at this, one second. He's saying that curly bracket A, so that is a set, belongs to curly bracket A, B, C. If we just look at generally, we'll say yes, A is present. So yes, it must belongs to. Now this is all about notation. Okay. What I told you, that for belongs to, that something should be present inside the set. Is curly bracket A present inside the set, or just A is present? A is only present, not curly bracket A. So that means it does not means belongs to. What if I want to correct this? So this is clearly wrong. So false. But how we can correct this? If I write A belongs to curly bracket ABC, that is correct. That here it is written element actually. So that element should directly be present inside it, whereas curly bracket A is not present inside. So that's why that's wrong. This is the correct. Okay. All right. Then x is such that x is an even number less than 6. For sixth part, I think we'll have to solve it. So left side, it's a even number, even natural number less than 6. So even numbers start from 0, 2, 4 and 6 we cannot write because it is saying less than. And then he's saying subset, another set, x is such that it's a natural number which divides 36. So natural number that is dividing 36 is 2, 4, 1 is also there, 1, 2, 4, 6, then 8 is not there, 12, I think that's it. 3 is also there, I forgot 3, 1, 2, 3, 4, 6, 12. Anything else? 18 is also there, I think. 18 into 2, 18. Oh, even number less than 6. Sorry, oh, one thing I missed. Even number, but he is saying natural. If I am saying natural, I cannot take 0, so that's wrong. So I have to erase this. So it's not present inside. Only 2, 4 is there. So 2, 4. Now this he's saying it is a subset of this 1, 2, 3, 4, 5, 6. 1, 2, 4, 6, 12, 3, 18. So all we have to do is look whether 2 and 4 are present. 2 and 4 are present or not. Yes. So it is also true. So this one is also true. Okay. So for subset we have to see whether these elements, all the elements should be present here. There will be extra, they may or may not be extra, but these all elements should be there at least. 2 and 4, 2 and 4 should be there. Okay. Now last kind of example for this, and then universal set separately. Let's focus on this. Last thing, this will help you to understand a lot about whether something is subset or something is belongs to. Okay. Okay. First thing, which of the followings, this is another example. So it's saying let A is a set. I told you about that. I gave you as example 1, 2, and then in curly bracket 3, 4. I told you that this is a element itself. Then which of the following statements are incorrect and why? So basically we have to tell whether this is correct or incorrect, true, false. First one, try to think, then I'll answer. Just giving you like 5-10 seconds. Try to think whether that is correct or not. 3, 4 in the is a subset of this. Yes, first one, true or false. So that's first of all, this one is Incorrect. Now you might think how. It is a set. It is present as it is in this. But for that, let's check out the second one first. You might be able to understand then better. Second one. What is that I told you about belongs to? Belongs to means that particular thing should be present inside the set. I'll rewrite itself. So A set is 1, 2, curly bracket 3, 4, then 5. Okay. If I ask you 1 belongs to A, that's correct or not? Yes, you'll say correct. 2 belongs to A. Yes, that is also correct. I told you to consider this 3, 4 as a single element. So that means curly bracket 3, 4 belongs to A. For belongs to, element is written 3, 4, although it is a set, but it is written inside a set, and right now we have to consider this as an element. So that is correct. So that means second one is correct. And clearly, if you can see second one is correct, I hope you can understand the first one is false or incorrect. Okay. Third one. Now try to think. How do we create subsets? If I take one element at a time, if I ask you to write subset of this, what will you do? You'll take one element at a time, start from there. So you'll write in curly bracket, you'll write 1. In curly bracket, you'll write 2. Why you're writing in curly bracket? Because you are putting element inside curly bracket. Remember that. Putting element inside curly bracket. So I'm writing curly bracket and I have to put this element inside this. That means I have to put curly bracket 3, 4 inside it. That is this third part. Curly bracket 3, 4 is subset of A. Yes, that is correct. I hope it clarifies it. Try to write it for one element. Try to write belongs to for each element. Try to write subset for each element. You'll be able to understand this all by yourself. Okay. Fourth one. Sorry. Try to think fourth one. I think fourth one I've written here. 1 belongs to it. So that is correct. Okay. Fifth one, if fourth one is correct, I'm pretty sure you are able to understand that 1 is not a subset unless and until we put a curly bracket. Okay. So element cannot be a subset. Okay. So fifth one is incorrect. Sixth one is 1, 2, 5 is okay. So he is taking 3 elements basically. So he is taking these 3 elements 1, 2 and 5 and putting inside a set. So I think that is correct here. Nothing wrong with it. So sixth one is also correct. Seventh one. 1, 2, 5 inside a set belongs to A. Clearly, if sixth one is correct, then seventh one is wrong. They should not be present inside a set. I have to write, if I want, I can write 1, 2, 5 belongs to A, but not in form of a set. I cannot put a set. If I put it in a set, it becomes a subset. So that is incorrect. Incorrect. Eighth one. 1, 2, 3. So see, again he is taking 3 elements. Okay. He is taking 1. I'm sorry. He is taking 1, no issue. He is taking 2, no issue. But this together is a single element. So how can he take only 3 out of it? Because itself they are single element. So if he has to take 3, 4 combined. So that means 3 cannot be taken as separately. So that means it should not be written here. So eighth one is also incorrect. Remember that 3, 4, either they will come together or they will not, because they are together a single element. Phi is a subset, so this one is correct. Phi belongs to, there is no phi present inside this. Phi is a subset of every set, but phi is not present inside A. There is no phi written inside A. So 9th one is incorrect, and 10th one is correct. Okay, 11th one. If I have to write subsets, remember I was taking 1 element, 2 element, 3 element, and so on, and I told you to take 0 elements. If you take 0 elements, and you'll say this is a subset of A. So basically this is what? Phi is a subset of A. Do I have to put another curly bracket here? No. That means this bracket is extra. That is making this incorrect. Okay. The correct way to write this is remove these brackets, curly brackets. Only phi is a subset of A, not curly bracket phi. That is a different meaning here. Okay. Try to redo this example. This will clarify your difference between belongs to and subset. This is all about notation. Remember that. If we are writing subset, we have to put it in curly bracket. We have to put elements in curly bracket if we are writing subsets. If we are writing belongs to, only the element should be taken, and then write down belongs to and then set A. Okay. All right. This clarifies this example. Slightly long, but yes, very good for conceptual understanding of belongs to and subset. Lastly, I'll take one concept called universal set. I have not discussed this in different types of sets because there is see, definition wise there is nothing here. You have to understand something. Universal set, what is the meaning of that? So basically if we are given some sort of set A, B and C, I have to write down one set which is subset of, so I have to write a set which is like ABC are subset of that universal set. Means all the elements that are present in ABC should be present in universal set. Okay, so if I talk about numbers, I think not in, you might think real numbers might be a universal set, but again it depends that from what perspective we are seeing. Okay, for particular given sets, natural number can be a universal set too. Okay, like for this, like A is given, B is given, C is given. We have to consider which can be universal set and which cannot. Okay, universal doesn't mean that it has to contain everything. It has to contain everything that A, B, C has, or D, even D is there, so A, B, C, D has. Okay, so we have to write a set which contains 1, 3, 5, 2, 4, 6 and 0, 2, 4, 6, 8. Okay, so if we look at this, 0 is there, 1, 2, 3 up to 6, but 8 is not present. So how can this be a universal set? Not possible. Phi does not contain anything. That means definitely cannot be a universal set. Okay, 0, 1 to 10. So 0 to 10, all the numbers are present. 8 is there, 2, 4, 6 is there, 0 is there, 1, 3, 5 is there. So yes, this can be a universal set for this ABC. Of course, there can be many universal sets, but this can be right now. So this is correct. 1, 2, 3 up to 8. Yes, it can be, but the problem is 0, which is present in set C, is not present here. So again, it cannot be a universal set. So basically, if I talk about universal set, it should contain A, it should contain B, it should contain C. A, B, C, like this. Then I'll call this as universal set. Consider this as a box. It's a big box which contain A, which contain B, which contain C in it. Then I'll call this box as universal set. Again, the size of the box can change. This can also be a universal set. So again, it depends from the perspective that what is asked. So they will give you a particular condition and then they will ask you what can be a possible universal set, and if in general it is asked what can be possible universal set, from subjective point of view we can write infinite universal sets as well, but from objective point of view you will be given options, so you can select that all the elements that are present in your universal set it should make ABC as subset, means all the elements of ABC should be present in universal set. Okay, I'll write down as a statement that will help you. All elements of A, B and C should be present in universal set that is being represented by U. Okay, all right, that's it. That was the last topic for today. We'll talk about upcoming topics in the next class. Okay, this chapter is not still over. Still we have to cover Venn diagram and union and intersection. Okay, so think of this as a half part of it. Today we just discussed different notations. What is set? Different notations, different types, subsets. Okay, just try to cover that, revise it. Okay, try to solve these examples by yourself after understanding. Okay, all right, that will be all. See you in the next class. Good day, everyone.